Now let's talk about velocity. So speed and velocity are very similar, but speed is just talking about a distance traveled, whereas velocity is talking about displacement over time. So just remember from before, or if you haven't gotten there yet, at the displacement station, displacement is just looking at the start and the end. So if you start here, and you walk to one end, but then you also travel back in the same direction and end up in the same place, then your displacement is 0. You didn't actually go anywhere different. Okay, so then your velocity would also be 0 because you had no displacement. Okay, so let's do a little bit of quick algebra review with formulas. So the velocity formula is pretty similar to the speed one. Velocity is displacement over time, so be very careful that you remember the difference between the two. But in some of these equations or these problems, you might need to solve for one of the different variables. So doing a little algebra, we can multiply both sides by t to get displacement by itself. So when we do that, we would have displacement equals velocity times time, because our times on that side would divide out. Okay? Finally, if we wanted to get time by itself, we could then take that one step further and divide both sides by velocity. So if we do this, then these velocities can't divide out, and that'll give me time by itself. Let me change that to an arrow. And time then is going to be distance over velocity. Okay? So something to note about how I call formulas certain things. This first thing is the formula, because that's how you would see it on a formula sheet. But then these two things, so what you've done basically is just rearrange the variables to solve for whatever your question is asking. I call those working equations. And they're really helpful because if you do the working equation first, then all you have to do is plug in your numbers, because they basically show you how to set up the problem. Okay, so let's look at one problem, at least to get started. Okay, so the first problem is talking about Justin, who walked to the grocery store, and how far away it is and how long it took him to get there. So because he went in one direction, so this is Justin, he went all the way to the store, and it took him, again, it was a distance of 832 meters. Okay? So because our formula is displacement over time, he only went in one direction, so his total displacement is 832 meters, and it gave you the conversion for seconds. It took him 300 seconds in order to get there. So 832 divided by 300 gives you 2.8 meters per second, and so that was Justin's velocity in question 1. I want you to try question 2 and 3, but think very carefully about displacement versus distance. Okay, so number 2 is kind of a trick question, but please try those next.